Okay, so we start the clip after the midterm exam. There are 3 chapters, right? So we start with the chapter 4. Right? Just talk about the functions of the several variables. Okay, so normally in the calculus 1, we talk only functions of the single variables. That means that you have the y is the variable depend on the free variable x. And in the calculus 2, when we talk about the functions of several variables, right? For example, functions of more than one variables, functions of double variables, right? So we have the term c, right? And depend on the value or the variable of the x and y, right? Or we can talk about the functions of the triple variables, right? For example, right? W, right? Depend on the variable x, y, z. Okay, you can see. So in general, if you write for the functions of the several variables, right? So we write that the term y, right, depend on the definite variables, right? From x1 to xn. Okay, that means that the variable y, right, depend on the term x1, x2, x3, right, until xn, right? That means that, right? Depend on the n variables. But normally, in this chapter, right, they're interested in functions of double variables, okay? And sometimes we can talk about that for the triple variables, okay? So, let's see. From the last chapter, we will talk about in the 3-dimensional space in 3D. So you can see that. And then compare to the in calculus 1, right, in the 2D. Okay. So when we talk about the functions of the single variables, okay, we plot the domain of the functions, right, on the x-axis. Right? So the domain of the function f is that related, right? X can be any real numbers, right? Which you have the term y equal fx. Okay. And then that means that, right, the domain, right, of the functions of the single variable, right, it's on the x-axis. Then the graph or the length of functions, right, also on the variable y. So after we plot, right, so we have like a graph, right, of the function f like this. Okay. And then for in the calculus 2, if we talk about the functions of double variables, okay, so you can see that the domain is the value of the point of the term x and y. That means that, right, the domain of the function f is the subset, right, of the value of the x and y, or that in R square. So if we write that, right, the domain of the functions, right, is the point of that x, y, right, in the R square, which c equal fxy. Okay. So the domain, right, also on the xy plane. Okay, so this is the domain of the function f of the double variables, right? So this is the domain. And then we will plot, right, a graph of the range. So it could be like, for example, right, that means that you have to see, right, in 3D, just like the how to say it, like a solid, right? So that this is the domain, right, on the xy plane, and then the graph will depend on, right, the graph of the function f. Actually, it's quite difficult, right, when we would like to sketch graph by use the hand. So we also can use like mathematical tools or the applications to plot the graph. Well, so to plot the graph, we will just plot the graph only for the domain of the functions of the variables. That means that we will plot the graph, right? So this is just the graph of the x and y plane, right? So we will plot like a graph, right? For example, right? This is the domain, right, of the function f. Okay, and then it's mapping, right, to the term c. So c is just the value, right, of the c. Okay. So for example, if we have the point, right, any xy, right, so also map to the 1 point, right, for example, right. So this is like a f of the xy, okay, for example. Okay. So now in the midterm exam, right, or in the homework, we will find the domain of the functions, right, and then we just plot the graph of the domain. Okay, so let's see the examples, right. So in the handout, right, they have the one problem 1a, right. They would like to find the domain of the function f, which defined by fxy equal y, right, child, with the 1 of the x minus y. Okay. So we have to use all the properties of the transcendental functions that you have to know, right? Just start with the polynomial functions, logarithmic functions, exponential functions, and trigonometric functions. Okay. So for examples, you know that, right? The domain normally, like the domain of the logarithm, right, or natural logarithm, right, must be positive. Okay. So, or we can write that, right, x greater than y. Therefore, we answer that, right? The domain of the function f is, could be, right, the domain in the two-dimensional space. Right? Then we answer, right, is any point xy or xy coordinate, right, in the R square, which is the condition that x greater than y. So you answer like this. Okay. For examples. Okay. And after that, we would like to know, for example, let's see about the sphere. Okay, you know, a ball or sphere. Okay, so that it's easier if we have like the center point, right, of the sphere is at the origin point. Okay, so you have, right, then the sphere, right, so you have, so please, right, so this is the sphere. Okay, and this is the domain, right, on the x1. So just imagine, right, if we follow this, right, so this is your sphere in the xyz plane. So you know, right, the equations, right, of the sphere, or sometimes we can call, right, it's ball, is if the center point is at the origin point, right, and the radius is r, so we got that. right? So this is, and then we can write in the term C, right? So C is equals like this, right? So the C can be, if we just talk about only above half sphere, right? Okay, so for examples, if we talk about it, C is the function G, it's just equals 16 minus x squared, okay, so C. And we'd like you to find domain and the range, right, of this sphere. Okay, so under the even rule, right, could be positive or greater than 0. Then we got that sorry, could be more, right? So it's less than or equal. Okay, 16. Then we can answer that, right? The domain of the function G is any point xy in R squared, right? Which, okay, these conditions, right? X squared plus y squared is that or equal 16. And then you have to find the range, right? So you can see that, right? If the radius is the 16, right? It's R squared. So we also found that the radius, right, also equal 4 units. Okay, so we got that, right? The range of this term is the value of the term Z, right? And then the term C is just the real number, right? Just only one dimension, which since this term is less than 16, right? So at least it could be 0, right? Or the maximum is also 4. Or we can answer in the closed interval, right? From 0 to 4, since this is just the real numbers, okay? For examples. Okay, then why we have to find the domain, right? Because, can you remember, right? The first topics in the calculus when we like to find the limits of the functions, right? Also, in the calculus too, we would like to find the limit of the functions too, but the functions of the double variables, okay? So let's start to find the limit of the functions. Okay. So for examples, we will write that, right? If you have, right, the function C equal fx1. And then we will find the limit of the function fx1. Okay, so if we compare to the functions of the single variables, right? And we find the limit, right, of the function f as x approaches to any point A, right? If the limit exists, then it could be in the set of the real numbers, okay? So this term, right? But the domain of the single variable is just only x. But the domain of the single variable is x1. Normally, xy is just point. So normally we could write in the term of the f of the point, right? F of the point x, x1. But it's more complicated to see, so we can write just to make clear that only the f of the point xy, but we already know, right? That the xy is just the coordinate, right? So both are the same, right? So we can omit of the one pass of the parentheses, okay? So just left only f of the xy. Then the limit might be the limit when the domain, right? So this could be right at point x, y, right, close to the point AB, for example, like this. So let's say that, right, the limit of the function f x y, right, as the point x y, right, approaches to the point AB, right, or when the x y close to AB. Okay, so if it exists, it could be equals to the any real numbers. Okay, so as the same with the single variables. Okay, so the meanings, can you remember if we write the meaning of the single variable, right? For the single variable, right, for the meaning that said that, right, for every epsilon, right, which is the positive, there exists at least one delta, which is the positive 2, and for every x is in the domain of the function f, right, if the absolute x minus a less than delta, we have to get that, right, the absolute fx minus l is also less than epsilon. Okay, so this is the mathematical definitions or the meanings of the limits. So if we transfer to in the meanings for the double variables, right, this also have that for every epsilon positive, they exist also the delta, and for every any points x, y, right, in the domain of the function f, this is the distance, right, from the point A, how to write, x minus a, okay, x minus a less than delta, right, absolute, that means that, right, the x minus a is between negative delta and delta. So that means that, right, the value of x is between a minus delta and a plus delta. So if this is the term a, right, so then we got that, right, so delta not more than this. So this is the point, right, a plus delta, right, and this is the a minus delta. Okay. So this is the value of the term x. Okay. But this is the 2D, right? When we talk about the distance, it could be like how to find, could be like a norm, right? I mean, right, the point xy minus the point AB, right, less than delta. Okay. So what this mean? This means that the distance into the, right, square root of the x minus a square, right, plus y minus b square, right, this must be less than delta. Okay, and then, okay, we should like to get, but okay, so fx is just in the one dimension, right, so just use the absolute sign of the xy minus l also less than epsilon. Okay, so this is the meaning, right, for the in the functions of the double variables. Okay. Well, anyways, who's proved this just for the mathematicians, but since we are engineer, we just apply this to solve this. Okay, so let's see the example, right? There are the main two techniques, okay, to solve this. So the first one, if you can replace the functions with the that make that, right, the zero is not equal to 0, right, so just replace the terms. Okay, so let's see for the examples. If we find the limit of the functions easier, right, x squared y cubed, right, when the x y close to the point 1 1, right, and then this divided by x squared plus y squared. Okay, so this is the limit of this function, right? The point x, y close to 1 and 1, and the functions of the x squared times y cubed, right, over x squared plus y squared. Well, we just replace the point x equal 1, right, and y equal 1. Okay, so this you can just replace, and it's not make the denominator equal 0, right? So just replace, right? Use, and the answer is the half, right? I can try it. But if the limit of xy close to 0, 0 of the point xy. Okay, so what happens? Be careful. Since the limit of this term is also equal 0, right? That means, right? So let's say in the next AP, right, how to solve this. And the answer is this limit does not exist. Okay, so let's see. Bye.